by Mr. Anoop Thomas and Mr. Nitheesh Kurian. Mr. Anoop Thomas is currently working as Assistant Professor in Electronics and Communication Engineering Department, Rajagiri School of Engineering and Technology, Kochi. He has an experience of about 16 years in academia, industry, and research. His domains of interest include digital electronics, embedded system, advanced microcontrollers, VLSI, and verification. He has published many papers in various reputed national and international conferences and journals, and also acted as the reviewer for various national conferences. He has a stint of around 1 year as a research assistant in the domain of autonomous vehicles under Professor Jürgen Trost, Erlangen University, Germany. He is currently pursuing his PhD degree under KTU in the domain of autonomous vehicles. He has been actively involved in various accreditation processes of the college and department. Mr. Nitheesh Kurian is working as Assistant Professor in Electronics and Communication Department, Rajagiri School of Engineering and Technology, Kochi. He completed his BTech in Electronics and Communication from the Srinarayana Gurukulam College of Engineering and MTech in Applied Electronics from MG University, Kottayam. He has an experience of 8 years, of which he worked with iGate Global Solutions and in various engineering colleges in Kerala. He has training experience in the Horizon Group also. On behalf of Government Polytechnic College, Kottakkal and the participants, I welcome Mr. Anoop Thomas and Mr. Nitheesh Kurian to this program. Handing over the session to you both.
Thank you for that nice introduction. Good afternoon and all. Me, Anoop Thomas, and my colleague Nitheesh will be handling this session on online tools or platforms for technical laboratories, practical perspective. First and foremost, I would like to congratulate Mr. Sriraj KP and his team from Government Women's Polytechnic College, Kottakkal, for organizing such a relevant FD. They also place on record our sincere gratitude for inviting us for this particular session. So that was the official part of it. Now I will proceed with my slides and what we are trying to present. Okay. So I will just switch off the video so that you will not have any bandwidth issues. Okay, hopefully the slides are clear. So I'll just start it off. So the idea here is we are trying to give you an option of moving your laboratory work, technical laboratories into the online mode. So I will speak about the basic methods that can be used, the various methodologies that can be used to do that. And once I finish off, this sir will be explaining about Tinkercad as a software platform or a platform on which you can do lots of labs. So we'll be explaining that with respect to certain examples from different domains. So that's the way in which we have arranged this particular session. Okay. So first, we'll go on to the particular practical perspectives of such kind of a transfer from offline mode to online mode. So we have kept the slides to be minimal. We don't have much slides because we feel that when you are taking something with respect to laboratories, it should be hands-on. So we try to focus our attention on doing things rather than on just speaking it out. Okay. So these are the topics which will be discussed in this particular session. So first, when you move from offline to an online mode of conducting labs, there are different choices that are available to you. So you have different modes in which you can conduct this particular lab. So I'll speak about the few modes in which you can do it, what are the advantages of each of these modes, and what is my experience while doing such kind of a lab. So that is what will be discussed in the first topic. Second is the method in which, the methodology of conducting the labs. So how do you conduct this particular thing? So that also you have different approaches to it. We'll speak about that. The third one, and the most important one, is to evaluate the lab. So you need to move into online, then conduct that particular lab using a method, and then evaluate that particular lab. So these will be the topics which I will be discussing during this particular presentation. After that, we'll move on to Tinkercad and the experiments based on Tinkercad. Okay. So first, we will speak about the different modes which are available. So basically, when you are moving from offline to an online situation, there are basically from my point of view, there are basically three methods in which you can do that. One is the student who is trying to learn this particular lab has a system with him. In that particular system, you will have installed, you will have the tool installed in it. The local system will have the tool installed in it. And then from your side, through your Google Meet or through your Zoom, you will be teaching this particular thing to the student, this particular laboratory to the student. So there are one type of tool is your Tinkercad, in which it is basically what is a browser-oriented tool, or you can install the tool. I mean, you need not install the tool. You can do the everything using the inside the browser itself. So that is one kind of a tool. The other one is the tool is small enough. The particular student can download it and then install it in the system, and then try to learn this particular tool. So you do the usual video kind of presentation to the student, and he will be able to catch it out and then do the experiment, then record it and place it in a drive, and then you will be evaluating it. That's the process. So the advantage of this kind of a process is that your networking issues are minimal. That means you are teaching a student who has already downloaded that particular thing. So again, the time issues. I mean, he can do it at any particular point of time. So he need not. I mean, networking, the timing issue or the related to the time and related to the network goes off, and you only require the usual online platforms to do that. That's the advantage of it. So we will be taking our particular session based on such kind of a tool called as Tinkercad. Okay. The second method that can be considered, or that can be implemented is remote access. So there are tools which cannot be downloaded and installed in student system. So for example, I come from a VLSI domain. So automatically we have a Cadence Virtuoso tool suite, which cannot be downloaded and all. So it's an institutional property. So what we do is we have our computers, labs available in Rajagiri. So we allow remote access of these particular these particular computers to these particular students. So they can remotely access these particular systems with a remote access tool, like different remote access tools are available which can be used to do that. And then they will be doing this particular lab remotely from their home, and we here will be monitoring that. So that's the second method. This can be done to high-end tools where licensing is an issue, and you have only few licenses which are available only in your college and lab. So for that kind of a setup, you can do this particular kind of online lab method. But again, there are huge issues with respect to network. We tried it for a Cadence, but we tried it for a number of approximately 10. We had 4 teachers who were trying to control it. Still, there were lots of networking issues, both at the student end and both at the institutional end. There will be a delay between the student moving it and then it getting reflected in the particular system. Again, certain students are faster, certain students are slower. We'll have to do the particular training with respect to the slowest possible student. So these are some practical issues which we faced. But again, for this kind of tools, this is the only option that is available. But again, as the number increases, if you speak about giving this kind of a setup for 60 students, it's quite difficult. The requirement of the staff is larger. Network issues might come up. All this will be there. So that is with respect to the remote access possibility. And the third and the most easiest of the online modes is your virtual lab. So the virtual lab can be implemented either by the institution in which you are working, or it can be accessed from a different institution. That means, for example, your institution will provide a platform which is quite similar to whatever you do in the lab. You will have the theory, you will have the simulation setup, everything will be there, and the student has to log in at some point of time and then do the lab. Or it can be provided from a different entity. That means MHRD has a virtual lab setup which can be accessed by anybody. It's there in this particular site, vlab.co.in. But so it's a very easy method of implementing online labs. This particular site has almost all labs, all basic labs, almost all engineering, all engineering subjects. But again, we had gone through most of these particular labs. We feel that it's not that, I mean, technological issues are there. Then we feel that on a lab or when you're teaching front, this is not that suitable compared to the other methods. This seems to be best suited for self-learning. Means we want to learn something by yourself. You can go to this particular site and access this particular labs. That's fine. But when it comes to what is a teaching kind of a setup, this seems to be lacking a little bit. So that's our feeling with respect to virtual lab. But it's very easy. If you want to start off a particular lab, you go to a site like this and see if your particular lab is there, and then give the particular thing to the student. And it is more focused on the learning part. Evaluation and all might not be that feasible. And different people will have different ways of interpreting how the lab is going to be done. So automatically that issue will be there. But again, it's an option which is available to you in today's world. I mean, even the government is promoting this, so you can also try out this particular facility. These are three different online modes. Now, so next is what is a method that is used to conduct a lab. So automatically you have two ways of doing it. One is the teacher being the driving force. The teacher decides everything. Teacher is the person who gives the lab. Teacher is the person who educates or who teaches the lab. Teacher is the person who evaluates the usual method. Where teacher is the king. We will drive the whole process, and we will do it similar to the offline setup. We will be the person who will be doing all these processes. Second, might be more fruitful method might be a student-driven approach. So when you speak about a lab setup, the lab requires a lot of peer-to-peer interactions. That means usual labs are where you will have one kind of a setup, and then it will be done by 3 or 4 students according to the requirement of the lab. So you have interaction between the students happening. That is how they learn. So that is completely lacking on the online mode. It's very difficult to introduce that in an online platform. So what I tried out this with respect to S4 batch for a logic design lab, where what we did was we selected 10 students out of the 50 students who were available, and then we taught these 10 students, and then we asked these 10 students to teach the rest of their peers. So we even gave the authority to evaluation. Evaluation also was given to them. So it was found to be effective in the sense the communication between the students will always be more effective, more free when students and students interact. So we tried this particular approach. We tried it using the Tinkercad platform, and it was found to be effective. So this is something which you can try. One option will be if you have 10 experiments, 5 experiments you do, 5 experiments you give to students, so that you have both the advantages of both these approaches in your hand. So these are two different approaches or two different ways in which you can conduct a lab. Okay, so I will just show you a video which will tell you how that particular lab was conducted.
Coronavirus has caused a pause to this world. From cities, towns, factories, multinational companies, transportation, and education. In India, universities and colleges are trying different online methods to teach their students. But most of the online classes does not seem as effective as one running their class. This is due to the lack of student-student interactive sessions. In order to overcome this situation, a 10-member student committee from CC Department of Graduate Student Engineering and Technology was selected to conduct unsupervised lab sessions for logic circuits and design. Prior to these lab sessions, we had a PDB class organized and taught by Nitheesh sir, also from CC Department, who introduced us to a new web browser called the Tinkercad. The lab sessions of logic circuit design are conducted on online platform called Tinkercad. In the class, we online that is used to create, design, and simulate the output of the circuit. It is automated the web browser and does not require any installation. It is easy to use and equally easy to learn. The class of 15 for the PCB department class were divided into 5 groups, each consisting of 10 members. And from each group, 2 students volunteered to teach their class. The lab sessions are conducted on a weekly basis as it would be done under normal circumstances. As part of the preparation for this task, 10-member student teaching committee meets every Sunday prior to the lab session to discuss the experiment activities. The students are given the liberty to work alongside their instructor or complete the task later as each session is recorded. The students do not shy away from asking their doubts as the instructor is their very own classmate.
We thank all the students who have taken up initiatives to make this lab session a great grand success. Without them, it was never possible. We also thank our teachers and faculty members who have provided us with ample amount of resources to make this a success. Thank you.
Okay, I guess the video was okay. So that was a video made by the students itself. As you can see, there are small issues. They told Tinkercad as an online browser. That's automatically expected from a student perspective. Anyway, the video was completely done by the students, and the whole process was completely organized and implemented by the students. We just gave them directions. The rest was all up to the students to do. So that might not be that feasible always, but again, that is something which you can try out and try to experiment with it. It will be a good learning curve for both teachers as well as for the students. So it was with respect to the conducting of labs. The third most important part when it comes to labs will be the evaluation of lab. How do you evaluate the lab? So you have 3 methods. I feel that you have 3 methods. One is the daily evaluation. That's the way that you do. But again, in online mode, daily evaluation might not be that easy because when it comes to an offline lab, you can just go around this particular laboratory and we know which are the students who are performing, who are not performing. That's there in our hands. So that is something which as teachers, we are easily able to recognize. But in an online environment, to understand who is doing, what is doing, has he really done this, it's very difficult. So the online, the daily evaluation using the usual method of checking the work that they have done might not be that feasible in an online lab environment. But again, it can be something which can be tried out. And automatically, the second option is your online MCQs, so the multiple choice questions given to students within a time frame. They're asked to answer it, and according to the particular marks, they will be able to. You'll be evaluating in them based on that. You have different portals, Google Forms, Quizzes, or Kahoot, which can be used to do that particular thing. That is another method, but I feel that on the evaluation front, the best option that can be used is Viva. Viva is where the teachers are the kings, or we know how to conduct a Viva. And Viva, it's not an easy for student to, let's say, shy out of a Viva or just fake the Viva. We will be asking for a video-based Viva, and we will ask questions based on the answers that he gives. Automatically, through Viva, we are really able to evaluate a student. So I feel that out of these 3 methods, I tried out Viva. Viva was found to be much more effective than the other methods. Okay, so this is a basic interpretation of what are the things which are required, what are the options which are there when you move your lab from an offline environment to an online environment. So you have different options, different modes that can be used. You have different methodologies that you can try out, and you have different evaluation strategies. Again, it's a new domain, something which we as teachers who have been doing the usual offline method is very reluctant to move forward, move into. But again, it's the demand of the time, and we will have to move into such kind of a scenario. So we'll have to try out different methods, and finally select which of the particular thing is most effective with respect to your lab. That's what I wanted to discuss with you. Now, from here on, before moving on to the Tinkercad and then the working of the Tinkercad, we'll do a small survey based on your experience on different online laboratories. So we have a poll which has been set up in this particular site, www.windy.com. You can go to this particular site and then enter this particular code 965829 and answer the questions which are given to you. Okay. So we will show you the result of this particular code. Okay, so what is to be done? So this is based on a site. So in order to do the poll, you can move to this particular site, that is www.mendy.com. In that, there will be an option of entering a number. That number is given here, 9658291. So once that number is entered, you will have a poll. You will have certain questions. You can just answer it, and then we will show the results. So this is one kind of a tool which can be used for such kind of presentations to make the thing interactive. So you exactly know how many number of people are listening to you. So on live you can see the results, the result variation. This particular questionnaire was just for our statistics to see how people are reacting to such kind of an animal. So this is something which you can use as part of your particular asset. So around 90 people have 90, 91. That basically means out of the 200 participants, only 100 was listening. Rest are either sleeping or stop. So that's part of it. I mean, students, teachers all remain the same. It's the same thing which goes on. Once the online mode came into picture, it's always easy to fake. That happens. You cannot avoid that. So this is just a snapshot of what I wanted to, what I want to convey to you. So the rest of the things. Okay. Anyway, so the rest of the talk will be taken by Nitheesh sir on Tinkercad. So we are trying to include 3D modeling, Arduino-based boards, and some kind of a programming as well in Tinkercad. So that doesn't stick to electronics domain. Okay. So that is something which we are trying. So in the time frame that has been allotted to you, we will try to make you understand the tool. You can do along with us, but again, we cannot wait for you to complete and then proceed. The time is a critical issue here. So, but again, you yourself can try it out by your side. We will do it in a very slow manner so that you can do it. So, what do you think?
Okay. Anoop, sir. So good afternoon, everybody. So as the poll result shown here, which your preferred mode for online lab session, most of the people are selecting web-based lab tools. So it will be very easy for me because today I will be discussing about an online-based tool or a web-based tool which is called Tinkercad, which is commonly used for designing electronic circuits and model 3D shapes. So I will be trying to include both of these because we are not concentrating on electronics domain only. So 3D modeling can be also do for mechanical as well as civil engineering. Similarly, computer science, electronics, all kind of students can do the same. Okay. So we'll be moving on to the Tinkercad sessions. So thank you for joining with the poll. So around 119, 120 people are already done the poll. So here you can see the results. So as Anoop sir said, mendy.com is a website which is used for creating interactive presentations. While you're doing online classes, you can do the same thing, or you can ask polls for your students and you can plot the graph. The graph will be automatically plot there according to as per the results. From the statistics shown here, you can see that around 120 people are already done the poll. And are you interested in conducting online lab sessions? Most of the people are very interested, and very few people are not interested to do online lab sessions. So you will get results like that. Okay. So quickly, I'll move on to Tinkercad session. I hope my screen is visible now.
Yeah. You can continue.
Sorry for the interruption, some network delay. So basically, Tinkercad is a web-based tool which is basically used for 3D modeling and circuit designing. So today I am trying to include 3D modeling as well as circuit designing. So first we will go for circuit designing. In circuit designing, we will be dealing with some LED-based circuit and Arduino-based circuit. Then while we are doing Arduino-based circuit, we will be discussing some programming like Scratch. You might have heard about Scratch and text programming. And if we have time, we will definitely do a small micro project. So first we will go for circuit designing. So before that, I will be sharing my Tinkercad screen here. So if you want to do along with me, you can do the same thing in your laptop or in your desktop. Using mobile phone, it will be a little bit difficult to do the Tinkercad. Go to Tinkercad.com. Tinkercad is basically a platform by Autodesk. So while you are login to Tinkercad, it will be asked for login with your Google ID, or you can make another account. So if you have a Google ID, you can sign up with your Google account. So this will be the first page when you log on to the Tinkercad. On the left side of Tinkercad, you can see that 3D designs and circuit. So you can do 3D designs and circuit in Tinkercad. So first, we'll be going for circuits. So when you click on circuits, you can see a library over there in which you can see already created circuits by you there. If you have already created different circuits, it will be shown there. And now I need to create a new circuit. So I'll be going for create new circuit. So when you click create a new circuit, it will redirect you to a new platform. This is a work plane. This is called work plane of Tinkercad. Here we are going to construct our circuit, right? So to introduce or to familiarize with the Tinkercad tool, first we will go for a very basic circuit in electronics, or very basic concept in electronics, or fundamental theorem in electronics. You all might have heard about Ohm's law. It's the potential difference between two points will be directly proportional to current, and when temperature remains constant. This can be demonstrated in your lab, even in your +2 labs, students who are doing the same thing. And similarly, in the first year electronics, students are also doing the same verification of Ohm's law in their lab. So with the help of a web-based tool or web application, how we can do the same, or how we can verify, or how we can manipulate the same circuit setup in Tinkercad. So for manipulating or for creating a circuit for verifying Ohm's law, we need a resistor. Definitely we need a resistor. We need a ammeter. We need a voltmeter. So before going to connect, see, just imagine a physical electronics laboratory. If you want to create any circuit, the fundamental thing that you want to make a circuit is breadboard. So similarly, here you can see a search button. In the search button, you can search for breadboard. There are different kind of breadboards: breadboard small, breadboard mini, and a quite normal breadboard is also available. So I'll go for breadboard small. And once you click the breadboard small, which will be available in the work plane, and you can drag your mouse pointer, and you want to fix the breadboard, just click once. Just click once, the breadboard will be placed over there. Okay, it's a mini breadboard, and I think you are familiar with the breadboard concepts, like the connection between the breadboard. So I'm not going into the detail of breadboards. So now I will take a resistor for connecting. Before connecting resistor, we need a power supply, right? We need a power supply to give power up the circuit, right? So when you search like power, or you can search like supply, you will get different battery, and here you will get a power supply. So again, I click on the power supply and drag it over here and placed here. And look at the power supply. you can zoom and zoom out the Tinkercad workplane using your mouse scroll button. You scroll it, it will be zoom, and scroll down, it will be zoom out. All right. So in the power supply button, you can see that a red button which indicates the positive supply, and the black indicates the negative supply. So I'll be connecting the positive supply. Simply click on that. You can draw the wire. So if you want to draw the wiring, just click on the positive pin of the power supply and simply move the mouse pointer, and I'll connect the positive connection to the breadboard like this. Okay. Similarly, the negative or ground will be connected to this point. So similarly, you can make connections between the components. And if you want to change the colors, so I need red color for the positive supply. You can give red color for easy identification. Similarly, green can be changed black. So this can be easily identified as positive and negative. Okay. So now we have to connect the resistor over here. Okay. So again, go to the search button. You can see a resistor over there. So I'll be connecting a resistor between the breadboard like this. Okay. So for the verification of Ohm's law, we have to measure the current as well as we have to measure the voltage. Voltage across the resistor and current flowing the resistor. So in order to measure the voltage and current, we have a multimeter. Search over there, multimeter. Okay. So you'll get multimeter over here. So place the multimeter over here. So again, the positive is shown in the red color and negative is shown in the black color. So I will be connecting positive side to the positive supply voltage and negative to the resistor in order to measure the current, because ammeter should be connected in series, right? And again, we'll take another multimeter for measuring the voltage. Okay, then positive should be connected to voltmeter should be connected across the resistor. So positive terminal should be connected. Sorry. Okay. Positive terminal should be connected on the top end of resistor, and negative is connected to lower end of resistor, and lower end of resistor should be connected to ground also. That circuit is completed right now. All right, I'll just reconnect the wires. Okay. So now the circuit is already completed. Now here you can see a start simulation button. So if you press the start simulation button, you will get the result. So when you press the start simulation button and see that the first multimeter is for current reading. So you have to change the voltage into current. So that you can see three circles over there. First one is A. A stands for current, B stands for voltage, and R stands for resistor. So click on. Similarly, on the second multimeter, voltage is already selected. Okay, ma'am, there is no code for this. This is a simple circuit which is not using any particular programming. Okay, if you need programming, you have to choose any kind of microcontroller like Arduino. This is a simple circuit which doesn't need any kind of programming. So now we are going for the resistor. Just click on the resistor. You can see the resistance value over here. The resistance value is 1 kilo ohm. And we are applying voltage as 5 volt here. You can vary the voltage in this knob. So again, I will choose 5 voltage. So since the resistance is 1 kilo ohm, the voltage is 5 and the current through the resistor is 5 milliampere. So V by I. V by I means 5 divided by 5 milliampere will be giving 1 kilo ohm. So if you want to change the resistor, see, I will change the resistor value to 2 kilo ohm, and you can see the color code of resistor. It will be changed while we are changing the resistance value. So when I change 2 kilo ohm, the color code has changed. So when it makes 2 kilo ohm, you can see that the voltage remains same 5 volt, but the current has changed to 2.5. Similarly, if we again change the resistor into ohm range, you can change the resistance range here: pico ohm, nano, micro, milli, ohm, kilo ohm, mega ohm, giga ohm. Right. So I'll change into ohm and make it 200. You can see that voltage is 5 and current is 25 milliampere. So when you reduce the resistance value, current has increased. Similarly, if you increase the voltage, again the voltage increases and so current increases. So this is a simple verification of Ohm's law that we are normally doing in a physical laboratory. I hope it is clear. So the same scenario can be reconstructed using a web-based application like Tinkercad. If you want to create a tabular column and all these things, you can take different readings, multiple readings, and make it in a tabular column, and finally you can draw the graph in a paper. So if you want to conduct a lab for verification of Ohm's law, you can do this platform and ask the students to do the same thing and take the readings and draw the graph. I hope it is clear. Shall we move on to next?
Yes, sir, please. Sir, please.
Yes. Thank you, sir. Yes. So I will clear all the components here. And now we are moving on to another example by using an LED. Okay. So here you can see LED is there and 9-volt battery is there. So I will pick a 9-volt battery in order to turn on the LED. So I'll place a 9-volt battery here. And if you want to rotate any component, on the top left corner you can see a rotate. Just follow my mouse pointer. On the top left corner you can see a rotate icon. Just click on that. It will rotate like this. Okay, and you can place it anywhere. Similarly, I just I'll move the breadboard a little bit. Okay, and again the positive of the battery, I will connect positive of the battery to positive of this positive side of this breadboard, and I'll make a connection to negative also. So I have made the connection of power supply here. Then I'll begin LED. Okay, and I'll connect an LED here. Okay, so while we are using an LED, while we are using any kind of electronic component, you should be very careful about the current rating of that particular device. So normally, most of the simulators are not validating that kind of information. But the specialty of Tinkercad is also validating such kind of information. So I'll connect anode into the positive pin of battery and cathode to negative pin of battery. So the connection has completed now. And if you start the simulation, you can see that the LED has blown out, right? And when you, if you point the mouse pointer over the LED, you can see a message that current through the LED is 915 milliampere. Presently, current through the LED is 950 milliampere. That is because we are using a 9-volt battery here. While absolute maximum is 20 milliampere for this particular LED. So Tinkercad is validating that much information. So in order to create a perfect circuit, perfect LED circuit using this Tinkercad or this simulator, what we do is normally we have to reduce the current. So then the question is, how do you going to reduce the current? How do you going to reduce the current?
By existing resistance.
Yes, definitely. We have to put a resistance over there. So with the help of Ohm's law, again, we can calculate the exact value of resistor because we are 9-volt here, and 9-volt is the voltage that we are going to apply across LED, and the absolute maximum is 20 volt. So V by I, that means 9 by 20 volt. 9 by 20 volt will be the exact current. So sorry, exact resistance value. So I will stop the simulation. So can you say what will be the value of resistance? The value is the value of voltage is 9 volt and the value of current is 20 milliampere. So could you please suggest me the value of resistance?
Approximately one.
Approximately. Sorry.
1K. Approximately 1K.
Approximately 1K. Okay. Right. Let's do with 1K. I'll make the connect. I'll connect the resistance across resistance to the anode, and which is connected to the positive terminal, and again the cathode terminal will be connected to negative, and I'll make the resistance as 1 kilo ohm. On default, it will be 1 kilo ohm. And when I start simulation, the LED is already glowed. Okay, but the brightness is very less. So our value of resistance is not optimum. That is why the brightness is very less. So what should be the correct value? I got a message in chat box, almost 330 ohm. Yes. So we'll try to make it as 330 ohm. Okay. So 330 ohm. While we are making 330 ohm, again you will get another information. LED has grown with more brightness, but there is, you can see that I is already grown there, or I button is there. When you place your mouse pointer over there, current through LED is 20.9 milliampere. So such validation is there in the CAD. So while recommended maximum is 20 milliampere, the usable lifetime of LED may be reduced. So 330 ohm is not the correct specific value of resistance. It will be something more. So let's make it 3. Yes, it's 450 ohm, another answer. So let's make 450 ohm. When you calculate it by 9 divided by 20 milliampere, it may be 450 ohm. So when you make it, LED has grown perfectly, no warning messages. So we have made the correct resistance over there. So why we are preferring Tinkercad? Yeah, 350 also work for me, no problem. So why we are preferring Tinkercad? Tinkercad is doing such kind of validation. While we are doing some other kind of simulators, most of the simulators are not doing such kind of validation. And so some other simulators, if you're connecting an LED directly with a battery, it will simply glow on. Okay, so that's all about LED with a battery circuit with resistance. If you have any doubt, you can post in the chat box or you can turn on the mic and ask. Otherwise, we'll move on to next session.
Can we plot the transfer characteristics and everything?
No.
Transistor
Sorry, sir. In Tinkercad, Tinkercad is not allowed to plot such characteristics like transient as well as DC characteristics are not allowed to plot here. For that, we require other kind of virtual system modeling like PSpice or Proteus tools will be used for such kind of transfer error analysis. In Tinkercad, we can do the real-time simulations like this. We are able to do the such kind of simulations only. I hope it is clear. Shall we move to next?
Yes, sir. Please continue.
Okay, thank you so much. So similarly, we can do another example using a motor. Different components are available in Tinkercad, so we'll try that components also. Yeah, sure. I got a question from Sri Shubha ma'am. Can this use for digital circuit? Definitely, you can. We can use. I will demonstrate one example later, ma'am. No problem. Okay, I will go for a motor. Okay, we'll choose a DC motor. So here also there are terminal 1 and terminal 2. For a DC motor, there are no specific positive and negative terminals. So I'll connect terminal 1 to positive, terminal, okay, this terminal, this one to connected to positive, and this will be connected to negative. And when you start the simulation, you can see that the motor is simply running and it's showing a RPM also there. So a simple hobby circuit, right? So simply connecting a motor with a battery, the motor will be simply running. But if you want to control the speed of the motor, what will you do? If you want to control the speed of the motor, speed of a DC motor, what will you do? Any idea? Sorry. Am I audible? Yes, yes, ma'am. We have to control the current. So, how do you control the current?
What?
I need to vary the speed at different instants. By using a resistor, you put a resistor, the speed is controlled.
Resistor, or we can.
Okay, if you're using a resistor, the speed will be limited to a particular value. I need to vary. Yes, exactly, sir. We have to use a variable resistor. So here I will demonstrate how to use a variable resistor in Tinkercad. Okay, so you can search in the search button that potentiometer. So here you can see a potentiometer. So in potentiometer you can see that the wiper is there, terminal 1 and terminal 2. So resistance is 250 kilo ohm here. So I'll be making it as 10 kilo ohm. And I'll be connecting terminal 1 to negative. See, I'm simply connecting terminal 1 to negative and terminal 2 to the first terminal of potentiometer, and wiper is connected to our positive supply. And when you change the wiper, you can see that RPM of the motor is changing. Okay, RPM of the motor is changing. Okay, now it is 422 RPM and 290, 271. So when resistor increases, the RPM is totally reducing like this. Okay, so now it is 112 RPM. Okay, so this is how we are using a potentiometer with a circuit. Similarly, you can use almost all the components. You can see that push button is there, potentiometer is there, and slide switch is there, coin cell battery is there, 1.5 volt battery is there, and different type of LEDs are there, photoresistor are there, ultrasonic sensor, PR sensor, all these things, piezoelectric sensor are there, temperature sensor, different components are there. Similarly, digital components are also available. You can do simulations using all these things. I hope it is clear. If it is clear, we'll move on to another example. Okay. So we are moving on to another example because we have very limited amount of time. So I'll delete all the components over here. So quickly, I will be moving on to Arduino microcontroller. So you might have heard about Arduino microcontroller, Arduino board, which is used for automating things, or we are using Arduino for developing circuits, which is programmable, right? As see, for example, if you want to make a temperature controlled device or a system which regulates the temperature, so we need a particular sensors, we need a controlling system like that. So we have to use a particular microcontroller for developing the system. So here we can simulate Arduino microcontroller in this Tinkercad. For that, first of all, you have to select an Arduino. So just type Arduino. So in Tinkercad, they're providing us Arduino Uno R3, which is very commonly available in the market, around 1,000 rupees. If you're going for the original one, you will get it for 1,000 rupees. And if you're going for prawn, you will get it for around 400 or 300 rupees, right? So this is an Arduino Uno controller. I'll be not going to the details of pin description and all these things or architecture details of Arduino. So you can see that there are different kind of analog pins and digital pins. This is very important. One of the major speciality of Arduino is Arduino can accept analog voltage as well as digital voltage. Why what is the importance of analog voltage in the sense? See, most of the sensors are providing analog voltage because sensors are as a kind of transducers which captures physical signals from the environment and convert into analog signal. So if you want to connect this analog signal into any kind of microcontroller, we have to convert that analog signal into digital. So that analog signal should be converted to digital data with the help of a analog to digital converter or AD converter. But if you're using an Arduino microcontroller, no need of particular ADC to convert this analog data to digital because we have inbuilt analog pins. So the output of sensor can be directly connected to analog pin. Alright. Similarly, digital pins are also available. Some of the sensors are we will get some of the sensors as a pack one or a module one. That module will give you digital data. So that digital data can be directly given to digital pins. So this is a Arduino Uno pin, and in Arduino Uno pin you can see on the center that just follow my mouse pointer. You can see a L here and TX are here. These three L, TX and RX are three LEDs which is available, inbuilt SMT LEDs available in Arduino. L is an LED which is connected to 13th pin of Arduino. Just above the LED you can see the 13th pin. The 13th pin is internally connected to this LED. Okay, and TX, RX LEDs are used for monitoring the transmission and reception of our serial communication operation of our Arduino controller. Okay, so let's go to a basic example or blinking of LED which is connected to 13 pin. So already we have an LED which is internally connected, or there are inbuilt LED which is internally connected to 13 pin. So similarly, again another LED externally to the same pin. So we'll take an LED. For the time being, I'll change the color red to blue or yellow. Let's make it yellow or make it blue. Okay, good. So, and I will connect this LED, the anode pin to 13th pin because 13th pin has already connected to another LED, input LED, and the cathode pin should be connected to ground. So, just near to 13th pin, you can see a ground. So, I will connect cathode to our ground. Okay. So, as we have did in the previous experiment, if you directly connect the LED, there might be a chance to blow out the LED because current will be huge. We will check later. So, if you see, while we are taking an Arduino in the Tinkercad, the Arduino will be having a default program or a preloaded program there to blink the LED which is connected to 13th pin. Okay, right. So we are moving on the code. So you can see the top right corner. You can see the code. When you click the code, you can see blocks here. See, blocks are mainly dealing with Scratch. Scratch is a very simple programming method, which is nowadays I think the Scratch programming methods are available in lower classes like 4th standard and 5th standard students are studying Scratch programming. So either you can use Scratch programming or you can use text programming. First, we will go for text programming and we will coming back to Scratch again. Okay. So in the drop down, you can see that block plus text and text. So I'll be choosing text here. So then Tinkercad is asking about, are you sure to continue to text editor? So I'll click on continue. Then you can see a code setup of Arduino. So when you program an Arduino board, the code environment of Arduino will be having two functions, not two loops, two functions. One is OID setup and one is OID loop. OID setup, in OID setup, we will be declaring all the variables, we will be defining all the functions and all these things. OID loop, as the name implies, OID loop is an infinite function. It will run infinite times, OID loop. But OID setup will run only once. So here, you can see that in OID setup, we are setting the 13th pin as output because we have connected an LED to the 13th pin, right? We have connected LED to 13th pin. So in order to turn on the LED, we have to make 13th pin as output pin, or we have to configure the 13th pin in the output mode. For that, Arduino will be having an inbuilt function or inbuilt syntax that pin mode. Pin mode in brackets, you can write 13. 13 means the pin number, comma, in capital letters output. Then 13th will be configured as output mode. Okay, so that's all for in void setup. Then going to void loop. So in void loop, we are trying to blink the LED. Blink the LED, that means turn on the LED for 1 second and turn off the LED for another 1 second. Okay, so for turn on the LED, we have to write a digital 1 or 5 voltage to the 5 voltage to the anode pin, and similarly to turn off the LED, we have to give 0 voltage to the anode. So 5 voltage in the sense, in the case of digital scenario, since 13 pin is a digital pins, we have to give logical high. That for that we can use digital write. Digital write 13 comma high. Okay, digital write 13 comma high. That means 13 pin will be having high voltage right now. That means 5 voltage right now. Okay. Again, we are calling another function called delay 1000, which is an inbuilt function available in Arduino environment. Delay will pause the program at that particular point for 1000 millisecond. Delay 1000 means 1000 millisecond. So it will wait for 1000 millisecond over there. Again, digital write 13 comma low. Then we are going for low voltage. Then again delay. And this particular loop will run infinitely. And you can see here, I'll be selecting one line that double slash wait for 1000 millisecond. Double slash indicates who comment the lines. Okay, double slash indicates the commenting the line. Okay, and now I'll be trying to run the code. Okay, when you start the simulation, you can see that the LED is blinking, and you can see a message over there. The current is more like 52.3 because voltage is around 5 volt, so current is less. So it shows a warning that LED, the usable lifetime, may get reduced. And just closely watch that the inbuilt LED, which is embedded in the Arduino board, is also glowing at the same time. The inbuilt LED, which is in the red color, just closely watch that both LEDs are blink with a 1 second delay. So if you want to change the delay, just stop the simulation and go to the program and just we'll make it as asymmetric, like one delay is 3000 and one delay will be 1000. Okay. Again, start the simulation. You can see that it will be turned on for 3 seconds. 1, 2, 3, and again it will off for 1 second. Again, it will be on for 3 seconds again. Okay. So this is a scenario how to blink an LED using Arduino. Okay. So I got a question that how do we burn hex codes on the microcontroller chip using this simulator? So if you want to burn hex code to this microcontroller, especially to Arduino, you have to use Arduino IDE. Arduino IDE is an open source platform which we can download from Arduino website. We cannot able to burn hex code from Tinkercad to Arduino. Okay, you can download the code. You can download this code, but if you want to burn Arduino board using hex code, you have to use Arduino IDE, which is available, which is an open source platform which can be downloaded from Arduino website. Then just put the code there and just upload it and connect the Arduino to your laptop or computer using USB and just upload it. It will be uploaded to the Arduino in the form of Xcode. I hope it is clear, sir. I think I got a question from. Okay, I hope
Sir.
it is clear. Yes.
Yes, sir. Doubts ഇപ്പോൾ നോക്കുന്നോ അതോ നമുക്ക് സെക്ഷൻ കഴിഞ്ഞിട്ട് നോക്കാമോ സാർ?
മതി. അത് മതി. Okay. Thank you.
Okay.
So that's all about blinking of an LED. And if you want to remove the warning, again, as we have discussed earlier, just connect a resistor over there. I'm not going to that because we already did that. Okay. Now I'll stop the simulation over here. Okay. Once again, we will check the Scratch programming for a curiosity. Scratch is again an open platform. You can either download Scratch application in your laptop or in your desktop. Also, we can use Scratch as an online platform, which is just getting started with Scratch. If you search that Scratch in Google, you will get an online Scratch platform over there. Scratch means it's a drag and drop programming platform. So here you can see that set built-in LED to high. First one is set built-in LED to high. So I will clear all the block here. Delete block. I'll delete all the blocks here. So here you can see that set built-in LED to high. So just drag to here, and if you want to make it high or low, you can just click on the drop down. And I need to set the built-in LED to high first. Then go to control. Then you can see different options here. Go to control. Wait for 1 second. I will choose wait for 1 second and drag here, and just join with the block and wait for 1 second, or I can change into 2 seconds. Again, go to output, set built-in LED to high. I will change high to low. Again, go to control, wait for 1 second. We will change into 3. Okay. So that's it. And start simulation. You can see that 2 to 3 seconds. 2 seconds on, 3 seconds off. Okay. And if you go to text, again you can see that the text will be automatically changed as per the Scratch code. We have made some change like 2 second on delay and 3 second off delay. When you make the changes in corresponding changes in Scratch, it will be automatically changed in the code. And if you change the text code, it will be automatically changed in the Scratch also. Okay, so both are synced. So that's all about blinking of an LED using Arduino platform. Hope it is clear. Shall we move on to next?
Yes, sir, please.
Okay, thank you. So now we are going to do a sensor experiment. So I will give a scenario. You just tell me that how to do that experiment. Okay, the scenario is very simple. I have so I need to make a system in which the system should turn on a bulb or turn on LED while light goes off or sunlight goes off. So after 6:30, an LED should turn on automatically. So you can post in the chat box, or you can turn on the mic. Okay, we have to use an LDR, right? Yes, we have to use a light sensor. So LDR should be there in order to detect the presence of light or not, isn't it? So what is the principle of LDR?
When light falls on the resistance,
So the resistance, see, LDR is a sensor which converts physical quantity light into resistance. So as per the light, depending upon the light, of light, resistance will vary, right? Okay. So as per the variation in the resistance, we have to turn on an LED. So that is a scenario. So for that, first of all, we have to I'll exit from this code. And we are going for an LDR first here. Okay, photoresistor. I'll take a photoresistor over here. So how do you make a photoresistor circuit? Photoresistor is a circuit which give you resistance according to the variation in light. So we have to make a potential divider network over there, right? So I will connect a resistor here. So for that, for the easy connections, I'll choose a breadboard also. Okay, and this 5 volt from Arduino is connected to breadboard, and again ground is also connected to our breadboard. Then we'll take a photoresistor. Okay, and another resistor. Again, I will rotate it. And this terminal 1, I'll connect terminal 1 to positive supply, and the other end of the resistor, the other end of the other resistor is connected to ground. So both has, see, this is a fixed resistance of 1 kilo ohm, and if when light falls on the photoresistor, the voltage across this potential divider network will vary. So I'll connect this voltage to, which is a varying voltage, which is not a digital voltage, which will be considered as the analog voltage, because which will be varying as per the light falling on the photoresistor. So I will connect that particular pin. So the potential central pin of the potential divider network to any of the analog pin. Let's choose A1 or A0. Okay, A1, A0, A1, A2, any of the analog pin. So I connect it to A0. Okay, I'll make it as a red. All right. So you will get the corresponding voltage variations in the analog pin. I hope it is clear. Then we need to turn on an LED. We need to turn on an LED when light is very low. So again, for a better, I'll choose a resistor, and cathode pin should be connected to ground, and this pin should be connected to any of the Arduino digital pin. Okay, let me choose pin number 9. Okay, this is the connection. Okay, so now we are moving on to the code, the programming of Arduino. Let's try to do the programming. Okay, so click on the code. So in the OID setup, we'll choose, we will connect LED to pin number 9. So we will choose pin mode 9 as output. Okay, then we have to read the A0 pin, which is analog voltage. So analog, we'll make a variable as LDR value, which is equal to analog read of A0. Okay, so A0 will be, A0 is analog pin, so which will be read by the command which is already available in the Arduino library, analog read, and the value will be stored to LDR value. LDR value is a variable. All right, and see, we'll use a serial dot print ln command. Serial dot print ln command LDR underscore value, which will be showing the corresponding analog value in the serial monitor. Okay, which will be showing the corresponding analog value in the serial monitor. So serial dot print ln is a command which is used to print the LDR value. LDR value is the variable which is used for store analog read of A0. Okay, all right. So let's try to start the simulation. There might be some errors, we'll check. Okay, so LDR value was not declared in the scope, so we have to declare LDR value over there. So int LDR value, LDR underscore value over there. So we have to declare the analog read also. So for that, so here LDR value we will be declaring it as 0. Int LDR value is equal to 0, and inside void setup, sorry, LDR value should be global variable. So we will be declaring above the void setup. It should be the global variable as per the C programming logic. It should be the global variable. So we have to declare as a global variable. Then pin mode 9 as output. Then again we have to begin the serial operation. Otherwise, serial print ln will not work. Serial dot begin, and we will set a baud rate. Baud rate is normally used for communication purpose. Here we are using that for simply print that LDR value to the serial monitor. Okay, so now LDR value is equal to analog read. Analog read, it is analog. A should be small letter. That is why it shown the error. Analog read of A0 serial dot print ln LDR value. Okay, now I'll give a small delay over here. Small delay. Okay, delay 100. So now it is okay. So now you can see that the serial monitor is showing the value 6. And in the breadboard, you can see when you click on the photoresistor, you can see a bar. Now it is dark. When it is dark, showing 6. When I increasing the bar to the light, that means this bar indicating that light is increasing. So when you increasing the light, the voltage is varying. As per the voltage, the serial monitor, the A0 pin is getting different values. So the value is between 6 to 679. So our intention is to turn on the LED when light is not there. So when light is not there, the value of the value of A0 is 6, simply 6. Okay, value 6. So I will give a threshold at this point. So let's take 362 as the threshold. Okay, when the value is less than 362, LED should turn on. Then we are assuming that there will be enough light, then LED should turn off. So we'll change the code accordingly. So just remember that our threshold is 362. So I'll as per the logic of C programming, just using a if loop, if LDR underscore value is less than or equal to 362, what should we made digital right pin number 9, right? Pin number 9 comma high. Yes. Else digital right 9 comma low. All right. So let's try to do the simulation. Again, we'll start the simulation here. Some errors are there. Digital right, the spelling is mistaken. D should be small letter. Okay. All right. So now the LED has turned on. Now we'll check whether it is working or not. Look at the serial monitor. Now the value of LDR, now the value of A0, analog pin is 6. Now I'll be trying to change the photoresist bar. Now it is 70. Now it is 118. Now it is 158. Still LED is turned on. 123, 204. It's 278, 301, 323, 343, 362 is our threshold, right? So I'm just making it as 379. LED has turned on according to our program. LED has turned off right now. So if you decrease the value, it is turned on, and if you increase the light, LED will be turned off. So similarly, you can interface any kind of sensors. See, photoresistor is giving always variable resistance. That is why we have to convert that variable resistance into an voltage value by using a potential divider network. And that voltage will be analog. That is why we are connecting the voltage into analog pin. If you have a complete module package of that sensor and which is giving a digital value, you can directly connect the digital sensor for that particular module into digital pins. Otherwise, you have to use analog pins. Okay, when you use analog pins, you will get random values. So in order to get a trial and error method, better to use serial.begin and serial.println. If you use serial.println, you can watch the different values of different analog values captured by the analog pin of Arduino in the serial monitor. So as per that data, we can set the threshold and apply the program accordingly. Hope it is clear. I hope it is clear. Yes, thank you so much for the feedback. So, shall we move on to another small? I have said that if we have enough time, we'll try to do a small project. Small project in the sense, as we have hit the COVID scenario all over the globe, automatic sanitizer is one of the most important thing in your daily life. So, I will show a small simulation, a very fundamental circuit which is used for doing automatic sanitizer very quickly. Okay, with your permission. So I'll show the circuit. I'll show the circuit very quickly because I had already made the circuit. I'll show the circuit and I'll explain the things because we have very limited amount of time. Only 25 minutes more. So I'll explain the circuit. This is the circuit. So this is a circuit which is not using any kind of microcontroller, so it doesn't require any kind of programming. It simply requires wait for a while. It doesn't require any kind of programming. So here you can see that we are using an iron battery here, and positive of the battery is connected to positive of the breadboard, and negative of the battery is connected to negative of the breadboard. And we are using a motor and PR sensor, so it requires only 5 volt. So we are using a regulator. This circuit is not complete because when you're using a regulator, it requires different values of capacitors that you might have already know that. I have not included capacitor connections in this circuit because without capacitor, the simulator will work. That is why I have not included that kind of details in this particular circuit. So this is a 5 volt regulator, especially 7805. 7805 is a 5 volt regulator which is commonly available in our market. So the positive terminal of the battery is connected to input pin of 5-volt regulator, and the ground pin is connected to ground pin of the 9-volt battery. Then output pin is connected to the output pin is the 5-volt. Output pin means 5-volt, which is connected to power button of PIR sensor. Okay, power button of PIR sensor, and this is signal button, and this is ground button, and ground button is connected to the ground of our battery itself, and signal button is directly connected to a motor, again which is connected to a LED, again which is connected to a resistor through LED through a resistor, and terminal 2 of the battery motor is connected to ground. Okay, similarly the cathode terminal of LED is also connected to ground. So when you okay, wait. Okay. When you run the circuit, when you simulate the circuit, in this circuit, the motor indicates that it is a submersible pump. It is an immersible pump which is immersed in the sanitizer. Okay. When someone, some person is placing his hand over the PIR sensor or below the PIR sensor, it will detect the presence of a person or an obstacle, and that particular signal will be given to the motor. Then motor will start running. So when an obstacle or when a person is identified by a PIR sensor, the motor will run and the motor will pump the sanitizer to the hand automatically. This is the scenario. So if you start, you can see that if you click the PIR sensor, you can see a range over there. And if you click over there, if you click over the range, click over the range, you can see that means the PIR sensor is detecting the presence and motor is running. When you release it, the motor stops running. Similarly, you are able to see that the LED is also turned on. Okay, so this is how the same circuit can be used to create or construct a automatic sanitizer in your home or in your college. It's a very simple circuit. So the same thing can be simulated in Tinkercad also. Okay, one of the most important specialty of Tinkercad is incorporating most of the sensors in it. So other simulators like other locally installed simulators like Proteus or Tinati and all other simulators are not incorporating much details of sensors. Even Proteus can do some experiments using sensors. Okay, so this is a best online web-based platform which can be used for simulating sensors and microcontroller like Arduino. All right, and as somebody has asked earlier, how we can use this platform for digital circuit, you can search over here the IC numbers. If you use 7400, you can see quad NAND gate. So the same as the wait. So if you search 7400, you can see quad NAND gate, and 555, you can see the 555 timer. So you can do the experiments, 555 timer experiments, 7400 NAND gate, AND gate, or op-amp 741. 741 operational amplifier. Different ICs are also available. You can do the experiment use of all these ICs in Tinkercad. So once you done one experiment in Tinkercad, it will be very easy for other experiment also. So my humble suggestion is try to do experiment with Tinkercad. Try to familiarize different experiment using Tinkercad. Then after 10 to 15 days, you'll be masters in Tinkercad. So that's all about the circuit section of Tinkercad. Quickly, within 5 minutes of time, we will be discussing how to model a 3D section in Tinkercad and how to export that model to a 3D printer. Okay. Shall we move, sir?
Please, sir, please.
Okay, right. So on the left side, you can see 3D designs. So if you have already created any designs, it will be shown there. And just go for create new design. So this is the work plane for 3D designs. So if you want to get the name board which should be fixed in your home with your name and your home name. So just click on a box and place it over here. So I am not going to the details of dimensions and all that. You can see that when you place the mouse pointer over here, it will show the dimensions in millimeters. So you can drag like in any direction because we are going to 3D model. So all degrees of freedoms are available here. So you can adjust the width, height, all these things. So adjust the width like this. And on the top left corner, you can see a top friend button. So if you change it, you can see that it can vary. You can rotate the work plane and you can see the shape of the model exactly. Okay. And okay, I will change the height also little bit. I will change the height also. Okay. So now I need to print my name. So here you can see a drop down, basic sheet, Tinkercad, characters, and different types of characters and connectors, text are available here. So I'll just take R and place over here. And similarly, I can increase the height. Want to increase the width over here and see, change the rotate this. You can see how it looks. Okay. I'll change the width little, reduce the height little bit. Then I'll take S again, place here. So accordingly, you can place any letters over here and align them with same dimensions. So the same, if you want to undo the undo operations, you can use Control Z. Over here on the top, you can see an undo button. Control plus Z is the undo button. So RS, then I'll place okay. So this is what I need to make and see. In order to fix the board, we have to use screws, right? So we have to make holes over there to fix screws. So again, go to basic shapes. Let's take the cylinder and place on the top right corner, and as per your screw size, make the size of the cylinder over here and click on the select the cylinder on, and you can see a dialog box here, solid and hole. Make it as hole. Okay. When you make it as hole, you can see a particular shades over there. Click on it again and click shift on your keyboard and select the entire board also. So you will be selecting both cylinder and the rectangle box. And on the top, you can see a group, Control plus G. When you click group, you can see that a hole has made over there. But a small mistake, the orientation is just gone. So I'll just change the orientation or alignment. And again, I'll be selecting the cylinder as well as the board using shift. Again, I'll make group. Then you can see that a hole has made over there. Okay. Similarly, next cylinder, I'll be placing over here in the same dimension. Then you can, if you want to copy and paste the same with same dimension and drag it on the other end. Similarly, again copy paste and drag it on the other end. Then select this cylinder and rectangle box again. Sorry, before that, you have to make it as a whole and select rectangular box also, make it as a group. Again, get a hole here. Again, this cylinder, make it as a hole. Then using shift button in your keyboard, select a particular cylinder as well as the rectangle box and group, you'll get another hole. Similarly, here also make it as a whole seed, then select that particular cylinder and box and make it as a group. You will get 4 holes, right? And if you change the top, bottom, left, front, can see that, see, the E is not on the box. It is just above the box. So you have to delete it and refix it again. Okay. So you can change the dimensions and check whether there is an error or not. If you closely look at that, R and S are not, the height of R and S are not same. So if you want to change the height, you can change it. Okay. And finally, after making all the changes, go to top right corner of Tinkercad window. You can see export, download, and 3D print. I hope it is visible. Okay. Click on export. You can see a dialog window will pops up, and you can see that for 3D print you can export in different formats. Most of the 3D printer will accept .stl format. If you want it, just click on .stl format, preparing model for export, and it will be downloading. If you click allow, it will be download into your desktop. See, it will be downloading into your desktop. Okay. And similarly, if you click export and on the next to download, you can see 3D print, and you can see different type of printers are already available. And if you want to directly give the print, you can select one printer. If I have a Astro print, just click on the printer and continue to Astro print, then it will print this particular model using that particular 3D printer. I hope it is clear. Nothing more about 3D modeling. Our humble suggestion is to trying different experiment using Tinkercad and use this facility for doing online lab sessions for the students also. Before going to do the online session with your students, you should be familiar with this Tinkercad. It will be very easy. Once you are doing experiments, you will be more interesting towards Tinkercad. And another important information is most of the organizations, especially foreign universities, are doing competition through Tinkercad for students. So if a student is aware of Tinkercad platform, they're able to participate all the competitions using Tinkercad. Because after doing a circuit modeling, for example, after doing a circuit modeling, I'll take 1 or 2, 3 minutes. I'll wind up after doing circuit experiment. You can share with some other person, because if I see, this is our sanitizer experiment, so you can simulate it over here, or you can tinker this, and you can share this link to some other person, and they can also do the tinkering with this circuit. So this is another advantage of Tinkercad. You can share the circuit designing or 3D designs that you have created in your domain, in your login with other persons. So once again, we thank the organizers of this particular program. Thank you so much for inviting us for this wonderful FDP and sharing our knowledge with you.
Okay, I guess we are done with our presentation. Have any feedbacks or questions?
If you have any questions or feedback, please share this. I will try to answer that.
The whole idea was, we are electronic circuits engineers. We are good at circuits. So we have focused our attention on circuits. I think more things can be done at the programming as well as mechanics. We have just introduced you to those stuff, but people who are good at those things can easily understand. And this seems to be a very good platform. And the important point here is, as I told you, we have tried it with a set of students. It's very easy for the students to catch it. The whole experience of Tinkercad is much better than usual portals. Again, we are not marketing Tinkercad. It's just that it's a good product. Part of any marketing.
So in between, I got a question that can we connect motor directly to the output of PR sensor? No, actually, while we're doing practically, better to use a transistor to drive the motor, because current will be very limited. So better to use a transistor while we are doing practical scenario. See, in simulators, sometimes motor will work, but in the real time scenarios, we are not able to do this experiment correctly. So try to include transistors for uplifting the current or amplifying the current. No, ma'am. This particular platform is only in online mode. It will work in online mode, and no other locally installed software is not available for Tinkercad. It's a web-based tool, so you have a proper internet connection for doing the experiments. See, for non-circuit branches, like if you are a computer science, if you are in computer science stream, for simulating programming, you can go for online simulators, like for Python programming or C programming, or different kind of online IDs are available. Online compilers are available. Just search in Google online compilers for Python or C programming. The same compiler can be used for different programming environments: C, C++, Java, Python, and different programming platforms are available in the single compilers. Civil mechanical CAD, I think CAD tools, online CAD platforms are available. I don't know much about that platforms.
We had inquired about these civil, mechanical, and computer science with other departments. We are from EC. So we are inquired about it. Generally, for the high-end tools, there is no option. Only option is suggested the remote access method, where your student will be able to log into the computer and do his particular work from his room. It's the only option available, but again, that is quite difficult to implement. I told you, we tried it with a particular tool called as Cadence Virtuoso. There was issues related to network connection. The student should have a computing system. He should have a stable network. Then there was a delay associated with it. A number of people were required to conduct the lab. So for a huge, big number of students, it's not easy. Small numbers we can manage. For say approximately 10 to 15, we can manage if we have staff. So any particular tool, online mode, remote access is possible. Any kind of tool, because it's just accessing that particular system which is here through the online, through the network setup. So that is the, but implementation it has its own difficulties.
If you are with desk or something like remote accessing tool, you can easily allow the students to do remote accessing with the systems or facilities available in your institution, and the students are able to do the same experiment in their home with proper internet connectivity. Any other questions, or sir?
So I think almost a majority of the questions have already been covered. So okay. I call upon Nishamis to do the feedback and the official.
One second. One more point. I told you, for any kind of labs, we have virtual lab setups. It's quite useful. You can just look into the. I have given the site ID. I will pass you the slides. So in that particular site, you have almost all the lab setup for basic engineering stuff. It's a MHRD based site, so there is no issue. There is no money associated with it. And you can easily go through it, but we found that there are certain things which are lacking in it. But again, at the minimal level, you can use this kind of vlab.go.insert. You there, you should be getting labs from for almost all. We have sent it across the chat. We have sent the particular link ID across the chat, so you can go through. That's it.
Thank you, sir. Thank you so much.
Okay. Thank you, Anoop sir and Nitheesh sir, for your informative session on the methods used to conduct laboratories online for circuit branches, and also information about other branches. Now you can hear the feedback from the participants. I invite Ms. Reena R., lecturer in electronics, Government Polytechnic College, Vennikulam, for providing feedback about this session.
Hello, ma'am. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, I am Reena, lecturer electronics, Government Polytechnic College, Vennikulam, Pathanamthitta. First of all, I would like to extend a warm thank you for Team Kottakkal for organizing an amazing training program for us. Today afternoon session by Anoop Thomas sir and Nitheesh Kurian sir was really informative and effective. The class on online web-based real-time simulator Tinkercad was really wonderful. The simulations on Arduino board, DC motor, LED blinking, 3D design, everything was really helpful. And also I appreciate how they're keeping everyone on track by showing online simulations and in between answering questions promptly. I once again thank you on behalf of everyone who were a part of the training session for making it a great learning experience for all of us. Thank you.
Thank you, Reena ma'am. Next, I call upon Mr. Arun Rajan, lecturer in Electronics Department, Government Polytechnic College, Kottakkal, to provide his words about the session.
Thank you, Joseph. Am I able?
Yes, sir.
Okay. It has been my pleasure for getting opportunity to thank the respectful resource persons of this session. In these Corona days, teaching and learning has become even more challenging, and the conduction of lab has become very stressful effort. In this scenario, this session has opened the door to teachers new innovative techniques to conduct the lab. Tinkercad is absolutely a great tool to perform lab sessions in effective way in today's situation. I extend my gratitude to Anoop sir and Nitin sir for introducing a new tool which will enhance the quality of our practical session. Thank you, sir.
Thank you, Arun sir. We end this session with a word of thanks from Mr. Sriraj.
Hi everyone. So when we had a plan to have this FDP, so the main hurdle that we were having is that how to have a session, how to include a session based on how to engage the labs for the students. Because as we all know as teachers, the main hurdle that we are facing is to engage lab sessions rather than theoretical sessions. So when I discussed with Anoop sir, they came up with a brilliant idea that how they were actually taking the classes, lab classes for the students. And Anoop sir and Nitheesh sir jointly, they came forward and to take a lab-oriented session, especially on Tinkercad, because there are people coming from the electronics and circuits background. And similarly, they have also introduced some of the tools which can be followed by the other teachers from the other program also. So from the bottom of the heart, from all the coordinators and the participants, I express a sincere gratitude to Anoop sir and Nitheesh sir. Thank you very much.
Thank you, Sriraj sir. We have come to the end of our 5-day faculty development program on tools and platforms for technology-enabled learning. Next, we move on to the valedictory function. I request all the participants to be a part of our valedictory function. Thank you.